Good morning, this is Mr. Precella, and today we're going to be working some examples involving economics, and they're going to involve functions, which we've been discussing for a while now. And so let's get to it. Let's see, what does it say? In macroeconomic theory, total consumption expenditures of goods and services, C, is assumed to be a linear function of national income. The table gives the values of C and I for 2004 and 2009 in country A, and this is in billions of dollars. Find the formula for C as a function of I, and then B, find the slope of the slope of the linear function is called the marginal propensity to consume. What is the marginal propensity to consume for country A from 2004 to 2009? So this is some really very good economics. But before we begin that, let's discuss a little bit about function notation once again. Here we're told that, let's see, C is assumed to be a linear function of national income. So C is a function of I. When we use our function notation, if we write F, this notation here, that means function of X. Okay? The of is what's called, the variable that comes after the of is what's called the independent variable. And the function of X, that's the dependent variable. This function depends on this value. It makes a lot more sense when you think of it in terms of consumption and income. To heck with thinking of it as a total national income. Let's just think of your household income or your own salary. The amount that you consume, spend in other words, depends on your income, not the other way around. If you just go out and blow a whole lot of money, that doesn't mean that your income's going to go up. Okay? The consumption depends on the income. C is a function of I. In other words, consumption depends on income. So, these lights are going to drive me crazy going on and off like that. So, this is the income is the X value. We're going to write an equation for a line here, and that's nothing new. We've done it numerous times already, except here you've got to figure out how do you write the ordered pairs. Well, first of all, these years here are not going to be anywhere in the ordered pairs. The ordered pairs are in the form I, comma, C. The income is acting like the X, consumption is acting like the Y. So the ordered pairs would go like this: 99.37, comma, 82.92. There's the first ordered pair. The second ordered pair, 12,029, comma, 10,092. Now this is on a much grander scale than your own, than just one person's income. This is the whole national income in billions of dollars. And so this would actually mean $9,937 billion. In other words, 9,937 billion. Doesn't it say it's in terms of billions? Yes. But even then, if you just think of it, if someone's making $99.37, if that's their income, this is how much they're spending in 2004. Now in 2009, they're making more. They're up to $12,000. They're spending that much. That's what consumption means, how much you're spending on goods and services. Ooh, let me lift this up. So now that we have the two ordered pairs, to write a formula, we're just going to find the slope. We're going to write an equation, y equals mx plus b. So, remember, when you have these ordered pairs listed like that, it's always x1, first x, first y, second x, second y. If you want to write them as i's, okay, but I think I'm just going to write them as x's, because when we state that slope formula, it's second y minus first y over second x minus first x. It's going to be sort of messy, these numbers. So let me see. Second y minus first y over second x minus first x. And just get a calculator. I'll just use the phone calculator shows up better on the screen. So let's see. 10,092 minus 8292. That would be 1,800 on top. Heck, I could have done that in my head. And then 12,029 minus 9937 is 2,092. Now, if we read further down in the instructions, they say to round your answer to 4 decimal places. So we're going to have decimals here. So let's just divide 1,800 divided by 2,092. And you see we get 0.86042. Again, the lights are flipping on and off here, so there's nothing wrong with your screen. 0.8604. That's the slope of the line. Normally we write lines y equals mx plus b, but let me go ahead and write it with c in place of the y. C. Oh, I want to C equals, let's go ahead and replace the m with 0.8604. And which variable are we using in place of an x? Well, I. Ooh, that capital I is probably going to wind up looking like a 1 before it's all over, but remember, it's an I for income, plus b. So now we need to find b. Well, have we done that before? Where you have 2 ordered pairs or just 1 ordered pair and you need to find the y-intercept? Well, sure. Only then we were calling them x and y. Here we're calling them I and c. So just choose one of those ordered pairs and plug it in. Remember, this is I, c. So I'm plugging 8292 in for c. I'm plugging 9937 in for I. And now it's a little bit messier than what we've been doing, but let's see. Real life usually has messy numbers. So let's see, 0.8604 times 9937. That gives us, let me see, I have 8292 equals 8549.7948 plus b. any of you students out there that are going to be majoring in economics, you'll do a lot of math. Okay? There's a lot of math in economics. I have a friend that works out at the university, a professor there, and I've read some of his papers, and oh wow, a lot of calculus and differential equations in there with some algebra thrown in. Okay? So now, it's not a pretty number, but how do we find b? Well, to solve for b, let's just subtract the 8549 from both sides. So let me clear that. I have 8292 minus 8549.7948. Notice once again it all talks about rounding to 4 decimal places, so we've rounded this one to 4 decimal places. And the others, there's no other place we need to round. These are all turning out to be 4 decimal places, right? So b is equal to negative 257.7948. So we're now ready to write the equation. C equals, oh, can y'all see this? Oh, there it went again. Oh, what was that? I think something fell over there. C equals 0.8604i plus b. Well, b is this negative number, so I'm just going to write minus 257.7948. So here's a nice formula for national consumption. So if someone asks you, what did you do in algebra today? You could tell them, well, we wrote a formula for national consumption given national income. Okay? So 0.8604i minus 257.7948. Okay. Now, oops. Then the next question, let's see. It's asked what's the marginal propensity to consume. You might be like, what the heck is that? Well, you got to read through the b up here. The slope of the linear function is called the marginal propensity to consume. What is the marginal propensity to consume? So they're asking you, what is the slope? Well, that's the 0.8604 that we found. So 0.8604. You might be asking yourself, well, why do they give it a different name, and what's the significance of this marginal propensity to consume? Well, the marginal propensity to consume is how much more you would be spending for every dollar increase in income. So this person or this nation as a whole is spending over 80, if their income went up by $1, they're going to spend 86 cents of it, okay? A little over 86 cents. They're spending 0.8604 of every dollar that they get, extra dollar that they get, okay? So that's how much they're consuming. So they're saving a little less than 14 cents of each dollar over this. As the income goes up, this person, this nation, is spending over 86 cents of every extra dollar they're getting. Okay? So some nice little economics there. So what do? You write your ordered pairs. Make sure you're going I, C. C is a function of I. That means I is the X value and C is the Y. So that's how I'm writing it. If you write it the other way around, then you're going to get the wrong answer. And basically you're saying that your income depends on how much you spend. And that's not true for anyone. The more you spend isn't going to raise your salary. Okay? But as your salary goes up or down, the amount you spend, the amount you consume goes up or down. Consumption is a function of income. And once you write your two ordered pairs, notice that 2004 and 2009 have nothing to do with it. Well, they don't become part of the ordered pairs. So, find the slope, then just use y equals mx plus b, plug an ordered pair in to find b, just like we did in some other examples. Okay? Here we're using the variables I and c instead of x and y. Okay? Now, let's see. Let's do another problem. I'm going to do two problems today. Here's this one. Let's see. Problem number 6. The graph provides a good approximation of the number of food stamp recipients in millions from 1994 through 2004 in some fictional country. I mean, don't use this as data in a real-life study. They're just randomly changing the numbers. Use the given ordered pairs to find the average rate of change in food stamp recipients per year during this period. Well, the rate of change, I'll write it right here. Rate of change, we've already mentioned that, is another way of saying slope. And what's that slope formula? Well, it's y2 minus y1 over x2 minus x1. Okay, second y minus first y over second x minus first x. So heck, it looks like we better write our ordered pairs, because that's what they're asking us to find, is the slope. So let's write out our ordered pairs. Ooh, the writing's sort of small. Let me write it bigger. 1994, comma, 28.5. Okay? That's the first ordered pair, 1994. So in 1994, in this country, whichever country we're talking about, there were 28.5 million food stamp recipients. In 2004, there were 22.4 million food stamp recipients. To find the slope, remember this is x1, y1, first x, first y, second x, second y. So m equals y2 minus y1 over x2 minus x1. Now, we don't need a calculator for the x2 minus x1 now, do we? 2004 minus 1994, that was a 10-year time span. So over a 10-year time span, the number of food stamp recipients went from 22.4 million to 28.5 million. So negative 6.1 million. So it looks, since it's negative, that's saying that the number of food stamp recipients decreased by 6.1 million people over a 10-year time span. When you divide that by 10, you would get a negative 0.61. So the average rate of change is negative 0.61 million recipients per year. 0.61 million would be 610,000. If you move the decimal point 6 places, or in other words, multiply that by a million. Okay. you take negative 0.61, it says million. So times 1 million. 3, 4, 5, 6. Oh, there it goes. The lights are, let me see if I can get them back on. Okay. So that's how much over a 10-year period, the number of food stamp recipients decreased by 6.1 million. So that means on the average, each year it was decreasing by 610,000. But you're not going to punch 610,000 anyway. I just want to make sure it's clear to y'all what that 0.61 million means. Just like 500,000 would be 500,000. So now let's interpret what this negative slope means. Well, just looking at the graph, you can tell that the number of recipients is decreasing. It decreased 6.1 million over 10 years. When you divide it by 10, that's telling you that on the average, it's decreasing by 0.61 million per year. The number of recipients decreases by 0.61 million per year. The answer would not be part A, where it says the total decrease of recipients over the 10 years is 0.61 million. No, it was decreasing by 6.1 million over the 10-year time period. Okay, so this slope is telling us on the average, the number of recipients is decreasing by 0.61 million people a year. Very much like what happened here in the United States. I suspect this problem is modeled after the United States, where the number of food stamp recipients started decreasing in mid-90s. Okay? But that's all the time we have for today, and those are the only two problems I wanted to work right now. So thank you for watching. Again, this is Mr. Precella. I hope you enjoyed it and learned something about a little bit of algebra or economics and algebra. Thank you. Bye-bye.